So we're going to start the next topic, which will be a continuation of the activator pattern that we started talking about last time. Now we're going to talk more about the implementation aspects of the activator. And then we're going to spend some time talking about some other patterns that we've been discussing as we've been covering the various bound services, proxy and broker. So first, let's talk about the second half of activators. So what we're going to do here is we're going to talk about how the activator pattern can be applied in the context of Android, or how Android applies the activator pattern. As you may have remembered from our last discussion, the activator pattern participants and the structure maps very, very nicely onto Android capabilities. And as we start talking about the implementation steps in the activator pattern, once again, it's remarkable how many of these things map kind of one-to-one onto what Android does. It's also kind of fun, if you take a look at the pattern description, you'll see that there's a number of different design alternatives that are described in the implementation section. And as we go through the implementation part here, I'll illustrate both the generality of the implementation approaches as well as describe how Android addresses those particular implementation choices in the things it does that pertain to activators. So the first thing to note that you do when you implement the pattern is you figure out what the services are and how do you identify them. And you also figure out what the service identifiers are, which are the ways you actually identify the services. So, of course, the idea is to encapsulate units of self-contained application behavior in the context of something called a service. That's the generic concept that's important. In Android, this is really easy because services are things that inherit from the service base class or from the intent service class. So services are real easy to figure out in Android. There's a one-to-one mapping between the concepts in the pattern and some realization of those concepts in the context of Android. And if you take a look at this link or this path name, you can find the code for services in Android, which is kind of fun to look at. The only real method that you have to implement is the onBind method, which is done for you by the intent service, but otherwise you have to fill it in to return null. And that's a way for it to tell the difference between different kinds of services. There's also the question of service identifiers. Now, in conventional networked applications that use the activator pattern, and we'll talk about a bunch of those later, typically you identify services via some kind of identifier scheme, like a universal resource identifier or a universal resource locator, or an interoperable object reference, or a TCP/IP host name or host address and a port number. Those are classic ways of identifying services in those environments. In the context of Android, of course, we identify services via intents. And there's a couple of different elements in an intent that are used by the intents framework in order to be able to figure out which services are being referenced when we go ahead and do a start service or a bind service. And some of those elements include things like what's the name, which is optional. You don't have to give it a name. You can leave it up to the Android intents framework to figure out what service matches based on other things besides the name. If you use the name, then it's basically an explicit intent. It's explicitly naming, says this thing goes with that particular entity. There's also other things like the action. What's the action that's being used? So is it some kind of action that relates to, viewing something or editing something, for example? Or, is it a URL action? You're going to download something. There's also the data that goes along with the action. This would be things like a URL or some other URI or path name that identifies either a local or a remote piece of content. So that's another thing that can go into an intent to help identify which service is responsible for processing the intent. Yet another thing that can go into an intent is something called the category. For example, there's a category for launchers, which are things that get up on the basic application launch screen. There's other kinds of categories of applications as well. So these are the kinds of things that are actually used by the underlying Android system and the activator framework, the Activity Manager service, which is the activator part of Android, in order to figure out who gets launched, what service to run when something gets sent out. You also then have to decide which services do you want to activate and deactivate on demand. And not every service that you might have in your system is worthy of being activated and deactivated on demand. So you have to kind of figure out a couple of things. You have to figure out things like what's the overhead for being able to activate something on demand or not. what's the downside to keeping something running for a long time? There are also, I think I should mention this too, there are also security implications. So some services are really important, and you want to make sure that they're always there. You don't want people being able to dynamically change them. For example, I don't think it's the case that you can dynamically activate the radio portion of Android, the part that does the actual phone management. That's the sort of turned on by default, and you don't activate and deactivate that. You can imagine that would cause all kinds of problems with probably missed calls because things would take too long to launch. So you have to figure out what it is that you want to be able to run dynamically and control dynamically. Some of the services we've seen on Android that do this, things like email, media playback services, services for sending and receiving various kinds of messages, short messages, multimedia messages, alert services that going to pop up when calendar timers expire and it elapse, and you have to alert someone that something is about to happen so they can go make a call or join a meeting or something like that. So those are some of the services that the Android developers have deemed relevant to start and stop in a dynamic way. If you take a look at packages, the packages apps directory, you'll find lots more examples of bound and started services there. And there's a bunch in Android as well in the frameworks part. The next thing you need to do is figure out what the service activation and deactivation strategies ought to be. And one of the key considerations there is what is the context in which a service gets executed, gets run. And there's a bunch of different choices. If you're programming in lower level operating system environments, things like the Linux inetd or Unix Internet daemon, inetd, that we talked about briefly last time, the super server model. In that particular case, you're probably going to have a process be the unit of activation. That's the service execution context. You're going to launch a process when something happens. In other environments, like if you're running in some kind of embedded system that doesn't have processes, you might spawn a thread. If you're running in the context of something like Android, if you think about what's being launched here, which is basically a service, that's really not a process or a thread. It's really more of a middleware-centric container of sorts. So it's an abstraction that it hosts some application logic. Naturally, it can run in a process or not, or it could run in a thread or not, but it's basically a somewhat higher level abstraction. So you have to decide what the right level of granularity is. Obviously, Android does it as a middleware container. You also have to figure out how the service is going to register itself with the activation framework. Is it going to do it dynamically by some kind of API call like register service? Is it going to do it more statically by defining various things in a manifest file so that when things get started, the system knows which place to launch and how to dynamically load the various resources in and so on? Those are decisions. Android typically goes with a static text file approach with a manifest file. You also have to decide whether the activation framework is going to be responsible for initializing the service or not. And there's a couple of different cases here. If a service doesn't require any initialization, if it just starts, then obviously the framework doesn't have a whole lot of work to do. If the service requires certain state, then it's up to the developer of the activation framework as to whether the activation framework is responsible for initializing the state, or whether the service that gets started is responsible for initializing its own state. In Android, anything that's important gets done by the service. It's not really done on a service basis by the underlying middleware. There's also another set of considerations about how do we deactivate services. So activating services is just half the battle. In the Activator model, once you activate something, you have to figure out how to shut it down. Of course, you could keep it running for an indefinite period of time, but to some extent that would defeat the purpose of an activator, because you really want to reserve or preserve resources or conserve resources by shutting things down when they're not being used. And there's a couple of different techniques you can use here. You can have the service trigger the deactivation. The service can say, I'm done, I'll shut myself down. That's kind of the way that intent services work. You can have the client trigger things. Some client can say, service, stop yourself. That's another model. And then you can also have things where the activator decides to shut stuff down. And that could be based on a variety of different things. Android supports all of these different models in various degrees, right? So with started services, when the service starts to run, it'll run indefinitely, and it has to stop itself by saying stop self. Or So that's the service-triggered deactivation model. Or another component could say, service, I want you to stop yourself. So that's a client-triggered approach. And of course, the Android runtime system might start to notice that memory is getting low, and it may say, hey, you got to shut yourself down. So that's kind of the activator-triggered model. With bound services, typically the way things work is that multiple clients can connect to the service, and as long as some of them or one of them is available and has a binding open to that service, the service will remain in memory. And we'll see some interesting sort of hybrid approaches in a minute when I show you some of the implementation code that appears in Android, how they deal with some of these issues. It's kind of cool. So you can take a look at the website. There's a link here that gives you more information about service lifecycle. But be aware that Android gives you all the tools to do the different kinds of deactivation strategies, and it's up to you to figure out what to do. The key thing you typically don't want to do is not let the service run indefinitely if nobody's using it, because that would be overly consumptive of resources. Some other things you need to do: figure out how you're going to interoperate between the activator and the service execution context and the service itself. So how do these things interact with each other? The key thing here is the interaction between the service execution context, which is typically either a process or a piece of middleware container, and the service, which is the thing that's doing the business logic that's defined by the end programmers. So there's a couple of different alternatives here. One thing that you typically have to do is come up with some way for there to be callbacks, either from the execution context to the service or from the service back to the execution context to do various kinds of things. Android supports both of these means, of course. The most obvious set of ways these interact is with the lifecycle callback hooks that are dispatched automatically by the Android runtime framework when a service starts, to call on create, when intent shows up via onStart command, when you do the various bind service calls, which trigger the onBind method, and so on. So there's a bunch of callback hooks that you can define, and those are interactions between the Android container infrastructure and your service and your hooks. And of course, your service can also make callbacks into the Android container infrastructure to ask it for various things as well. But that interaction is something that's very stylized and important to understand. Then you also have to figure out how to implement the activator, actually do the activation. And in Android, this is done by something called the Activity Manager service, which you can take a look at. It's a very, very complicated piece of code, very large. And it handles activation for lots of things: activities, services, broadcast receivers, and so on and so forth. It plays multiple roles. Even though it's got the name Activity Manager service, it manages other things besides activities. There's a couple of issues to consider here. When you design the activator, do you want to have a singleton activator or a shared activator that's used by all the services running in an infrastructure in an environment? Do you want to have one that's exclusive on a per service basis? Do you want to have some kind of distributed activator where you may have some centralized node that's keeping track of who gets to run and where they run, and so on? And again, there's no one size fits all or one right solution to all these different design considerations. The trick is to figure out what the alternatives are and then make the choices that make sense for you. In Android, they have essentially a singleton or shared activator. The Activity Manager service is the guy that is the role, the component in Android, the service, the super service that activates other things. Another consideration here is, what is the degree of transparency with respect to activation? Is this something where the application client has to make a special call to get a service started, and then it does other requests? That's what's called explicit activation. Or is it something where you just make a method call and the underlying activation framework activates the service implicitly and without you having to think about it directly and do something special? So the way it works in Android, which is different from other pieces of middleware, by the way, is you have to do explicit activation. You have to say start service or bind service, and then that triggers the service to be started, and then once that happens, then you can send messages back and forth. Now, you can also, to some extent, kind of do a little hybrid thing where you can pass in an intent or extras with the intent that goes along with the original service. So there are a few kind of things that straddle the line between implicit and explicit. But in technologies like Corba, we'll see later that there's much more support for implicit activation. You just make a method call, and boom, something magic happens under the hood to get the job done. So what I'd like to do now is take a tour through a piece of an interesting service in Android that demonstrates the use of Activator. And I'm just going to look at a part of it now. Later, when we talk about the broker pattern, we're going to come back and look at the full-blown glory of this stuff, because it's really cool and it's got lots of interesting interactions. This implementation, by the way, actually has a lot in common with the download file stuff you're doing that's the asynchronous version, because it relies on passing in asynchronous callback objects using one-way methods that will not block the caller while things are taking place. What this thing is, it's a network settings activity, and you can use it, if your phone supports it, in order to be able to find out what carrier networks are available. You know, so like you don't often see this too much when you're in the US. Usually you're with a single provider. You know, your phone just starts up and it's running with Sprint, or it's running with AT&T or Verizon. When you go overseas, however, oftentimes you're roaming, and there will be a range of different network providers to choose from. And so this particular network settings app or activity allows you to be able to see the networks that are available, and then you can conceivably choose one that you want to use. So here's basically the way this works, and by the way, all the source code is available. You can take a look at that if you're interested. So they have this network settings activity, and it has an onCreate method, and so when you launch this thing, it turns around and it makes a call to start service. And it invokes start service to go ahead and launch the network query service. But it doesn't talk to that directly, of course. It talks to the activity manager service. And the activity manager service takes the request and all the other things, and then it goes ahead and it launches the process to run the network query service if it's not already running. So that's really the Activator part right there. So it's activating it on demand. And then what happens is there's an opportunity that the service gets to initialize itself via its onCreate hook method, its lifecycle hook method, and it goes ahead and does what it needs to do. And then what's interesting, and we're not going to look at this in any detail right now, but we'll come back and look at this later when we talk about the broker. The next thing that the activity does after it calls start service is it turns around and it calls bind service. So this is kind of an unusual model. It calls start service followed by bind service, which looks a little weird, right? So far we've only looked at services that called start service, which are started services, or services that called bind service, which are bound services. But this is an example of something that does both. And if you read the comments in the code, it basically says it does this so that when we call start service, the service will remain running indefinitely. So we want this service up and running all the time. And then we call bind service, so we get back a binder object, and we can interact with the service by using asynchronous binder communication via one-way AIDL calls. And we'll look at that in a little bit more detail later. But I thought that was kind of an interesting example of using start service to explicitly activate something that will remain around, and then use bind service immediately after that in order to get back a proxy that the client can use to invoke methods on the service. So it's sort of a hybrid approach. But the key point there is that it has the examples of the Activator. It launches a service on demand. Any questions about that? So again, if you're curious, take a look at the source code. It's got a whole bunch of really cool things going on there. It registers a handler with the underlying radio interface layer, which is the part that actually keeps track of the service, the carriers, and the network availability. And when things change, there are callbacks that get made in the service. It's really cool. So we'll look at that later. Okay, so to go ahead and summarize this particular discussion, Android started and bound services use the Activator pattern. And as you can see here, they use the stuff that pretty much straight out of the book. Looks just like what you'd see there. These services can be run in different execution contexts. Most typically, if you don't do anything to the contrary, they end up running in the same process as the caller, which is typically an activity. But without too much effort, you can tweak the Android manifest file to say, I want this thing to run in a separate process, so it can then be launched in a separate execution context than the context that was originally calling it. And if you want to be able to do threads and have the service run in a thread, then you can program that by inheriting from intent service or doing something else not unlike what you guys have done for your programming assignments to implement multi-threading on the service side. Okay, so that's basically Activator. To recap, what we talked about last time. Activator is a pattern that makes it possible to launch things on demand, and we talked about sort of the pros and cons of that. Then we just saw some examples in Android where it gets used in order to work with launching bound or started services to do various behavior processing on behalf of the client applications.